Hello everyone, I hope everyone is having a great day when they start watching this video. We're going to start learning about atoms today. So just the basics of what an atom is, how it's made, and then a little bit of how to calculate different amounts of the things inside. So our first question is just to get us to start thinking about maybe what an atom looks like, or trying to get our brains working for the day, is what is the smallest material that makes up everything? What have we talked about before that's really small that we know kind of makes everything up? We've learned this year about some cells, we've learned about macromolecules, we've learned about proteins and amino acids, for example, but everything that we just said is made up of actually atoms. Also, we'll talk a little bit about some revolution stuff today. So I'm curious, how does the Earth move around the sun? So we have, when we think about our planets, how do they work? Do they go in a circle? Do they go in an ellipses, which is kind of like an oval? Do they just stay stationary? So we'll talk about a little bit of orbits as well. So I thought it was a good idea just to think about our solar system with our Earth and our Sun, to think about that. So by the end of the day, we're going to be able to describe the four main parts of an atom and understand how to find how many protons, neutrons, and electrons are in each atom. So we got a video for you guys to watch. This is a really good basic video to describe and show what an atom is, so please watch that now before going through the rest of this. But what we're learning about today is that we have four main parts of our atom. We have the nucleus, which is the center of the atom, and it contains protons and neutrons. I like to draw a connection back to our nucleus of our cell. So our nucleus of the cell was kind of the brain, or the very, I would say, most important organelle that we learned. So our nucleus of an atom is the inside, the center. We have a proton, which is a positively charged particle on the inside, and this is also equal in the number, or equal to the amount of electrons. So for every proton, we have an electron, and we'll talk through more of that later. We also have neutrons, which are neutrally charged, and this is equal in mass to a proton. So a neutron weighs just as much as a proton, but it's neutral. So our proton is positive, our neutron is neutral. P goes for positive, N goes for neutral. And then we have an electron, which is a negative. So our electron is negatively charged particle found on the outside. So if we look at this little carbon molecule, we can see that on the inside we have our nucleus, which is always kind of moving. In pictures we see it just stationary, but it's actually moving like this always, just like our electrons are. But we can see maybe the red ones we're going to call protons, and then these green ones, these green little balls, are neutrons. And on the outside, on the gray ones, we have our electrons. So let's talk through this second part of our proton. It's equal in number to our electrons. Why is that? So our overall carbon molecule does not have a charge on it. So that's because we have just as many positive charged particles as we do negatively charged particles. So since we have, for example, if we had 6 positively charged particles and we had 6 negatively charged electrons, our positives and our negatives would cancel each other out. It's like adding a positive one and then subtracting 1 from that. We go back to 0. So there would be no charge. So in most atoms, it's neutral, and we'll talk about some special cases a little bit later when it's not. But our electrons, the other important thing is that they're incredibly important for bonding. Most of chemistry happens because of our electrons. So we'll learn more and more about that as we go through the semester, or through the partial, I should say. So another important thing is to distinguish between valence electrons and total electrons. So our valence electrons are electrons just in this last shell. So we can see our first shell, our first circle in here has 2 electrons. Then our next one has 8 electrons. 8 little circles like this, and our last one has 8 electrons as well. So our total, 8 plus 2, would be 18 electrons, but our valence electrons would be 8. And why is that important? Our valence electrons is where the chemistry happens. It is the reason why certain things act the way they do, and atoms with the same number of valence electrons will act the same. So, regardless of how many shells there are on the inside, so maybe we didn't have this last shell, maybe it was just this first shell and this second shell, it would act the same as an atom that had a third shell because they both have a valence electron of 8. And then our total electrons are a little bit of an electron. So, is every little bit of an electron. Every little circle we see is the total amount, but our valence is our last shell. So, I want you guys to draw your own in your notes, which this is a very simple version, but it has everything I'd like you guys to have. So we have our nucleus on the inside, which is our inside part. We have a proton, and we always put a positive for our proton. We have a neutron, which we usually just leave as a circle, and then an electron, or multiple electrons, that we have as a negative. I would like to see as many electrons as we do protons, though, when we're drawing our own. Now, we're going to learn about how does the amount change with each element. So, we're going to learn how to read what each one of these look like. These are called our atomic symbols and numbers, and this is what our periodic table looks like. We'll be able to read these and then kind of work through some examples. So, we said earlier that our proton is, we didn't say this earlier, but our proton is equal to our atomic number. So the number of protons we have is equal to the atomic number. As the atomic number increases, so does our number of protons. We said our number of, our number of neutrons is equal in mass to our proton. We said that earlier. And as the element gets bigger, the number of neutrons increase, of course. And then our electrons are equal to the number of protons and the atomic number, unless it's an ion. We'll learn about ions a little bit later. But so for now, we can say that our protons are equal to a number of electrons, and our number of protons and electrons are equal to its atomic number. So, when we're looking at something like this, we have a few important things. This first thing is a full number, a full integer, in the either somewhere on the top usually, and it's called the atomic number. So, every atom has a different number, 1 through I think 188, and they each have a different symbol so that we don't have to write out the full name. So the full name is hydrogen, the symbol is H, so we can just write H and be very quick with it. And then the last important thing about this is we have a relative atomic mass, or usually we just call it the atomic mass, and this is how much a element weighs. So we have number, so the first one is hydrogen, we have how much it weighs, the atomic mass, and these numbers are going to be important for us, but also the symbol and the name is what we get. So, let's try a few. I'm going to work through these with you guys. So, given iodine, we want to be able to fill out the rest of this chart. So this chart is asking for the atomic number from iodine. So we look up here on the top of our picture, we see a 53. So, our atomic number is up here. Our atomic weight is always going to be bigger than our atomic number. So when we look at this, our atomic weight is this number right here, and we'll shorten it to 126.9. And then now we have to be able to find the rest of these numbers. So our number of protons is always going to be equal to our atomic number. So always this column is going to equal this column. So we're going to put a 53 here. And then the way we find our number of neutrons is we said they're the same weight as our number of protons. So what we can do is we can take our atomic weight, so let's do 126.9, and we can subtract our number of protons, 53, to find our number of neutrons. So I cannot do that very quickly in my head, so I'm going to do it using a calculator. So 73.9, but we're going to round up to 74. So we have 74 neutrons, and then our number of electrons is equal to our number of protons, unless it's an ion, but we haven't learned about ions yet. So let's look at some things that we can see. These three numbers are going to be the same for now. So these ones all were the same number. We were able to read this number from our picture, and then we had to calculate only one number. So it was pretty straightforward, other than this last little neutrons that we had to calculate. So let's look through a few more to give you guys some more examples. So this one is Caesium. Its number is 108, so I'll type in 108. Its atomic weight is 269. We said the number of protons was 108, and because it's not an ion, we're going to say the number of electrons is 108. So these three are going to be the same. And now we have to find the number of neutrons. So I like to do a little subtraction problem like this. And then you guys could either do this by hand. If some of you are smarter than me and can do it in your head, that works too. Or we can use a calculator. So our calculator just said that our number of neutrons was 161. So let's go through another example. So we can always keep changing up our element and just fill in these examples. We're going to see the same patterns. So our number is 117. Our weight looks a little different. It's a little bit higher up here instead of down here as we've seen it. But our weight is 294. Our number of protons is always equal to our atomic number. Our electrons are going to be equal to our protons. And then we would solve this by subtracting our number of protons from our atomic weight. So like this. And then again, I'm not smart enough to do this in my head, so we're going to do it this way. 177. So 177 is the number of neutrons. So this is our answer here. So that's how we are able to calculate the amount of, given an element, we can find its atomic number, weight, number of protons, neutrons, and electrons. But what if we were given this part of the table and asked to find the rest? So let's do it this way. We know that our atomic number is going to be equal to the number of protons. So we're going to say 5. We also know that the atomic weight should equal the number of protons plus the number of neutrons, because we've been doing it the other way for subtraction. So this is supposed to be 5 plus 10. So this would be 15. And then we're going to use our periodic table and look for the element number 5. So I actually have one here. Number 5 is boron. So we're going to put our element is in boron, B. So we can go either way with it. Given this information, we can find our element, or given our element, we can find this information. So I know that it was just a few examples. We'll practice lots more as we continue to learn more about this, but this was just an introduction. If you guys have questions, please let me know. I hope you have a great rest of your day.